In this video, I'm going to show you how to monitor a third-party application like MongoDB or Mysql or any other service in Kubernetes using Prometheus. So our setup is going to look like this. We're going to have a Minikube local cluster. And in the first part of this video series, I have already deployed a Prometheus operator using a Helm chart. So if you want to know how the deployment works, how to install the Helm chart, and what are the components that get created when the chart is installed, then you can check out that part first and set up Prometheus operator in your cluster. And then you can continue with this video. After that, in the cluster with Prometheus running, we're going to deploy a MongoDB application, and we're going to expose the data of MongoDB or metrics of the MongoDB application using MongoDB Exporter. And once the metrics is exposed through a MongoDB Exporter, we're going to allow Prometheus to scrape this data or these metrics. And we're going to do that using another component which is called Service Monitor. So along the process, I will explain all of these concepts in detail. I will explain what Exporter is, what Service Monitor is, so that you also understand the concept and then see how to use that in practice right away. And finally, once we've configured all of these and Prometheus starts scraping the MongoDB application through the MongoDB Exporter, we're going to see the new Prometheus target in Prometheus UI, and also we're going to see the scraped data visualized in Grafana UI. So with that, let's get right in. So to get the maximum out of this video, I do recommend to follow along the tutorial as I walk you through all the deployment steps and configuration steps. And a prerequisite for that is to have a Minikube cluster installed. So with that, let's get right in. For starting Minikube cluster, basically you can execute this command, which starts the cluster with more resources than the default, because we are going to use a little bit more resources because Prometheus Operator actually creates a lot of components, so it may need more resources. I'm going to put the commands for starting your Minikube cluster and installing Prometheus Operator in a Git repository for you to just copy it from there. And once you have everything set up, we can go ahead and deploy our MongoDB application. So this is my cluster. I only have Prometheus pods running on it. So I have a Prometheus Helm chart. This is the version of the chart, and this is the version of Prometheus Operator application. And here we can see all the pods of Prometheus. We have Grafana, Alert Manager, Prometheus Operator, and the Prometheus application itself. And we also have all the services, the chart installed. So the first thing we're going to do now is expose Prometheus UI so that we can see actually what endpoints are currently being scraped. And this is all out of the default. I haven't configured anything yet. So in order to expose Prometheus UI, we're going to use kubectl port forward command. So this will basically allow me to access the application that is running inside Minikube VirtualBox, to access it on my local host through a browser. So I'm going to do kubectl port forward service. This is the Prometheus application. And then I'm going to need the port that it's running at. And this command will expose Prometheus UI at localhost port 9090. I can actually copy this and type it here. And here you see Prometheus UI. And on the status targets, I can actually see all the targets that are being scraped out of the box. So if I close all this, I have a list of all the endpoints. So Prometheus is monitoring itself, the operator is getting scraped, etc. So what we're going to do in our setup is we're going to deploy a MongoDB application, and we're going to add MongoDB to the list of targets so that its metrics will also get scraped. And as I said, this is all out of the box. I haven't configured anything. And the way this works is actually through a component called Service Monitor. And before we move on to the Service Monitor, I want to thank Octeto who made this video possible. Octado Cloud gives developers instant access to manage Kubernetes namespaces. That means you can focus on developing your application while they manage the infrastructure in the background. If you want to try Octado Cloud, check out the special offer in the video description below. So if I go back to my cluster and I do kubectl get service monitor, I see a whole list of service monitors that the operator chart actually created. And these are exactly the service monitors that generate these targets list here. So these are exactly the same components. Service monitor is a custom component. We can also see one of the service monitor components here. Let's actually take Grafana and see its YAML file. And here you see it's a kind service monitor, and you have this configuration file with labels and the specification. So you have the endpoint, etc. You don't have to understand all the attributes here. There's one thing that is important in this service monitor, and this is the label called release Prometheus. Now, why is that important? Because this label allows Prometheus to find service monitors in the cluster and register them so that it can start scraping the application or endpoint, which is right here, of the application that service monitor is pointing to. So here you see it's pointing to Grafana at metrics endpoint. And this attribute basically allows service monitor itself to be discovered by Prometheus. And this logic of how Prometheus actually discovers service monitors using this attribute is configured in Prometheus itself. So I'm going to show you that as well. So in order to see the configuration, we have to check it in the CRD. So these are all the CRDs that Prometheus has created, and these are basically custom components for Prometheus. So this one right here, so we're going to check its configuration file like this. And in this configuration file, here we have the specification, all the different configurations. And if you scroll all the way down, this line here is interesting for us. It says service monitor selector, match labels, release Prometheus. So basically this says match all the service monitors that have a label, release Prometheus. So this means if you create a service monitor component which doesn't have this label, it will not be discovered by Prometheus. Cool, so now we understand how these targets got actually created, or target endpoints using the service monitor. Now as a next step, we're going to deploy MongoDB, and we're going to configure everything so that MongoDB becomes one of the targets for Prometheus to collect its metrics. So let's do that. So first we're going to create MongoDB deployment and a service. So pretty straightforward. I have this configuration file already created here. So it's basically a simple deployment, MongoDB image and port defined here, and we're creating a service for it. Pretty straightforward. I'm also going to provide the YAML files that I use in this video in the repository, so you can use them from there. So I'm going to apply this in the cluster. Exporter, and our deployment and service got created. So I have MongoDB pod getting created here. Cool, so now we have MongoDB pod running, and this is probably the typical scenario where you have an application deployed in your cluster, and at some point you decide that you want to monitor it using Prometheus. So the way to do that is using a component called Exporter. So each application like MongoDB, Mysql, or Redis, Kibana, whatever application you have, is going to have its own exporter, right? So exporter is basically a translator between the application's data or application metrics to metrics or data that Prometheus will understand. So it's basically sitting between the application and Prometheus, getting the data from the application, transforming it into data or metrics that Prometheus will be able to collect. An exporter itself will expose this /metrics endpoint so that Prometheus will be able to scrape it from there, right? So it does two things. It collects the metrics data from the application and converts it to data understandable by Prometheus. And the second thing is it exposes these metrics at a /metrics endpoint for Prometheus to be able to scrape them. So this is the role of exporter. An exporter can be a separate deployment in the cluster independent of the application, which is a good thing because when you decide to monitor your application later, you don't have to change the deployment configuration file or service or anything. You don't have to touch the application. You just create an exporter. If you don't want to monitor it, then you just delete the exporter and that's it. So now the question is, how do you find an exporter? How do you know there are exporters available? And how do you install it? So let's go back to the browser, and here I'm gonna type Prometheus Exporters. And on official Prometheus page, you can actually see the list of all the exporters available for different databases, hardware related stuff, messaging systems. So basically for a lot of different applications, there are already exporters that you can use instead of having to create them, right? And here, if you notice, in the Prometheus Operator that we installed, there is a node exporter that gets deployed out of the box. So this is one of the exporters, and as the name says, it is translating the metrics of the node, of the cluster node, in this case Minikube, into data that Prometheus will understand and exposes that metrics data at /metrics endpoint for Prometheus to scrape it. So here, let's actually look for MongoDB. There are some of them which have official next to it are from Prometheus itself. So if I click on that, I actually end up in a repository of MongoDB Exporter. These exporters are also available as Docker images, so you can also search them on Docker Hub actually. So if I write here MongoDB Exporter, then I will find a list of a lot of MongoDB exporters which are managed by different communities, and you should probably go with the one that has been recently updated. So for example, this one right here. So you can actually find if there are any available like this. Now there are three things or three components that you need to have when you deploy an exporter. So first of all, it will be the application itself in Docker image, that the exporter application that will expose the metrics endpoint. Then you would of course need a service so that Prometheus can connect to the exporter. So we're going to need a service for that. And with that, you would have an exporter running in your cluster ready to be scraped. However, as I mentioned, Prometheus must know that there is a new application ready to be scraped. So we have to tell Prometheus, hey, there's a new endpoint that you need to scrape here. And we do that, as I mentioned, using this component, which is called service monitor. Right? So we're going to need that component as well. So we're going to need to create a service monitor for our MongoDB exporter application. Now, we could of course go and create all those three component configuration files ourselves. So we can create a deployment, service, and the service monitor and put together all these attributes. Or my preferred way of doing it, we can search for a Helm chart that already has all these configuration files ready and configured so that you can basically just install them with one command. So let's go back and check for MongoDB Exporter Helm chart or chart. And this is the first one in the search. Here it says deprecated. This is something that happens often with Helm charts. They get deprecated, they're moved. A lot of them have been moved to Prometheus community Helm charts, so they're managed by the community. So always watch out for the deprecated so that you don't install something that is not maintained anymore. So we're going to follow that link, and this is basically the list of all the charts managed by Prometheus community, and here we have the list. And here is our MongoDB exporter. You have one for Mysql, Postgres, etc. So let's go inside, and this is our chart. And that's how we are gonna install the exporter in our cluster. Now, there are two things that we need to configure for this chart before we install it, right? Remember, if you have watched my Helm chart and explanation videos, you know that Helm charts are basically a bundle of all the configuration files you need to deploy that complete application, in this case, the deployment, service, and service monitor, with default values. But if you want to override some value, if you want to configure something, then you have a possibility to do that using parameters or chart parameters for that specific chart. So how do you know which parameters you can override, or what are the names of these parameters? You can find them either in the documentation. Sometimes they have a list of those parameters. This one doesn't. But we can also do that using Helm show values that will basically show you the list of all the parameters that this chart accepts. So first, let's actually add the repository. Let's clear this. Has been added. And now I can do Helm show values. And we need a chart name. So Helm show values chart name will actually show me all the parameters that I can configure. And this is actually a YAML file. And I can actually save them into values.yaml and open it in the editor. So these are all the default values, and you can override any one of those. So there are two things that we need to override. And let's actually get rid of all of this till here. And here you see service monitor configuration. And we're gonna need to override this additional labels attribute, right? So these are the two parameters that we need to override for our chart. The first one is pretty obvious. We need to tell MongoDB Exporter how to connect to MongoDB, right? So we need to give it a service endpoint so that it can connect to the independently running MongoDB. So the endpoint is going to be MongoDB protocol and MongoDB service, that's the endpoint, and the port, right? So at this URI, MongoDB is accessible. Now the second parameter, service monitor additional labels. Remember I showed you this release Prometheus label that all the service monitors in the cluster have, right? This release Prometheus basically is a label that allows Prometheus to discover or to automatically find a new service monitor in the cluster. And this chart by default doesn't add that release Prometheus label to service monitor, which kind of makes sense because that label can be different. So we have a possibility to add that label to the service monitor component that the chart will create. So let's add that label right here. So additional labels, and I'm gonna say release Prometheus. So now we have all the parameters we need for this chart. So let's go and install it. I'm gonna copy the chart name again. Let's clear this. Helm install. Let's call it MongoDB Exporter and the chart name. And of course we want to pass those parameters. So I'm gonna do -f values.yaml. So the chart will take the values file as an attribute, and it will apply all these parameters that we set here. So I'm gonna install it now. And let's check. We have MongoDB Exporter, and this is the chart version. So it's 2.8.1, and our pods or our pod must be running already. So this is the pod of the exporter. Let's also check that the service was created. Here we have exporter service, which exposes the metrics port. And let's also check that the service monitor was created. kubectl get service monitor. And here is our service monitor. Let's actually check that the label is there. And here you see release Prometheus. So cool, everything looks good. So the first thing that we can do is check the endpoint of the exporter at /metrics. So let's see what data it's collecting. So let's print out the services again. So this is the service, and let's do port forward on that as well. Service, and this is the service port. And let's check it. Here we have the metrics endpoint, and at /metrics, we see all this data being collected from MongoDB. Awesome. So the exporter is exposing the metrics for Prometheus. And since we have the service monitor also created with that release Prometheus label, Prometheus must already have discovered our new service monitor in the cluster, and it should already be scraping that metrics endpoint of the MongoDB exporter. So if I go back to the Prometheus UI, and if I refresh this, see we have the MongoDB exporter endpoint, which was automatically added to the targets without me having to change the configuration file of Prometheus. And we have the state, which is up, and configuration file, which is much more convenient than having to go and change the configuration file, reload or restart the applications, etc. So what we can also do now is check those metrics data in Grafana UI, because that's usually the reason why we're collecting the metrics, so that we can visualize them. So let's go back to the command line, and I'm actually going to expose Grafana deployment. So I'm going to do kubectl port forward deployment, and it's called Prometheus Grafana, and its port is 3000. And it is secured by default credentials. You have admin, and Prom operator is the default password. It says in the documentation. I'm going to put all this information as well in Git repository, and we're logged in. So if I go, for example, to manage, and if I go to pods here, I can see in the default namespace, I have MongoDB deployment in the dropdown. So I can see some of its metrics that has been collected. And of course, you can do some other visualization in Grafana from this metrics. So this is basically how you can configure metric scraping for any application in your Kubernetes cluster so that it can be monitored by Prometheus. You can apply the same concept for any other application like Mysql or some messaging services, etc. So I hope you learned a lot. Thank you for watching, and see you in the next video.